we want to find the antiderivative or evaluate the indefinite integral. Let's begin by factoring out this 4 and write this as 4 times the integral of x to the 4th sine squared x to the 5th. Notice how we have x to the 4th here and x to the 5th here, so we'll perform U-substitution and let u be equal to x to the 5th, and therefore differential u equals 5x to the 4th dx. And since we have x to the 4th dx, let's divide both sides by 5. Therefore, 1/5 du equals x to the 4th dx. So writing in terms of u, we'd have 4 times the integral of, well, x to the 4th dx equals 1/5 du. So let's factor out the 1/5. And then we have differential u. And then x to the 5th is equal to u. So we have the integral of sine squared u. So we've made some progress, but we don't have an integration formula for sine squared u. So we'll have to apply a power reducing formula given here, where if we have sine squared u, that's equal to 1/2 times the quantity 1 minus cosine 2u. So here we have 4/5 times the integral of, performing this substitution, we'll have another factor of 1/2. We'll have the integral of the quantity 1 minus cosine 2u. And now we'll find the antiderivative with respect to u. Notice here we have 4/10 or 2/5. The antiderivative of 1 with respect to u would just be u. Now you need to be careful here. When we integrate cosine 2u, we would have a u substitution. Let's call it a v substitution, where v would be equal to 2u, and therefore dv would be equal to 2 du. So if we divide both sides by 2, notice how du equals 1/2 dv, which means we'll have an extra factor of 1/2 when finding the antiderivative. So we have minus the antiderivative of 1/2 cosine v, which would be 1/2 sine v. But of course, v is equal to 2u. And then we have plus c. For the last step, we'll substitute x to the 5th for u. So we'll have 2/5 x to the 5th for this product. And then for this product, we'd have minus 2/10 or 1/5 sine 2x to the 5th, and of course plus c. This would be our antiderivative. I hope you found this helpful.